Assalamu alaikum wa rahmatullahi wa barakatuh. We are group 1 and our topic is about predator-prey model, the Lotka-Volterra predator-prey model. I am Omar Mansour and my matric number is 209416.
Hello, my name is Arabian Ibrahim and my matric number is 213351.
Hello, my name is Li Pengyu. My matric number is 213781.
Now we move on to the introduction.
So, introduction for the brain model, Lotka-Volterra. The first point about the introduction, the brain model, it has developed independently by Alfred J. Lotka and Vito Volterra. The brain model describes how change in brain and predator population influence each other over time. Second, the brain model, also known as the Lotka-Volterra predator-prey model, is a mathematical concept used to analyze the instructions between predators and prey models in ecosystem. Third point, this model assumes that predator population depends slowly on the availability of prey, with the prey population growing without restrictions in absence of predator. The last point, the brain model helps researchers to understand the dynamics and interdependencies when they're using a system of coupled differential equations, providing insight into ecological instructions between predators and their prey. That's all for the introduction.
For the principles, the model uses the equations to describe change in predator and the prey populations over time. The growth of a predator's population depends on the availability of prey, and prey population growth is the effect by predations, pressures, support, PTs, and response the predators populations at time t, and HT response the prey populations at time t. The change in the predators population over time can be expressed as dp of dt's equal to alpha h minus beta ph, where alpha is the efficiency with which the predators converts prey to new predators, and beta is the speed with which the predators controls prey. Similarly, the change in the predation's population over time can be expressed as dh of dt's equal to gamma ph and minus delta h, whereas gamma is the growth rate of the predations in the absence of predations, and the delta is the predations mortalities due to predations. And this model's determines is a balance point at the equilibrium point at which predators and prey populations is the stable balance state. We set the rate of change of predators and prey populations to 0 to achieve balance conditions. This result is a two conditions alpha h minus beta pH equal to 0 and gamma pH minus delta h equal to 0. And next page. Application is this model has many applications in the ecological research, conservation, biologies, and nature resource management. It helps us understand and predicate the dynamics of predator-prey interactions in real ecosystems, provide insights into the stabilities and the resilience of ecologic communities. It's also valuable for assessing the impact of predations on endangered species and design effects conservation method. In addition, the models can help develop sustainable pest control methods. For example, the model can help control pest outbreak without the use of chemical pesticides, distract fishers management to prevent overfishing and maintain the balance of marine ecosystem. Okay, that's my part.
So as you can see in the example, the trading record from the Hudson by company revealed cyclic fluctuations in snowshoe, hare and lynx population. Lotka and Volterra proposed the Lotka-Volterra predator-prey equations in the 19th to 20th century to mathematically describe such dynamics. Next, please. So as you can see in the first example, the Lotka-Volterra predator model is including linear terms of represent to the exponential growth of prey in absence of predator and the decline of predator in absence of prey. So as you can see, U multiplied by T plus delta T equal to U T plus alpha delta T, which is the change of time, U multiplied by T minus gamma delta T U T and velocity multiplied by the time. And you can see in the second, V T plus delta T equal V multiplied by VT plus exponential gamma delta T U UT VT minus beta delta T VT. And for the second formula, du over dt equal alpha u minus gamma uv comma dv over dt equal to exponential gamma uv minus beta v. And the third one is x dot equal to function of x and y, and comma y comma equal to j x and y. And the last one is x0 equal to x star plus exponential elements of 0 and y0 equal to y star plus plus wait a minute, delta 0, where x elements 0 and the delta 0. Next. And here, like almost the same equation, but in different differential equations. So xt equal to x star plus elements t, and yt equal to y star plus delta t. And the third one is the elements dot equal function of x star plus element y star plus delta. As you can see, delta equal to g the bracket x star plus element of y star plus delta. For the last one, f and x equal to f, the first zero will be the x, and the second one will be the y0, plus x fx, which is 0 and 0, plus y fy, and also it will be 0 and 0 because we can see in the figure in the reports or the equations, and plus half, and then when the other bracket x squared fxx, so will be same 0 and 0 for both the x, plus 2xy fxy. So here we use the x0 and y0 also, plus y square fyy, which is also 0 and 0, and then we continue to the last of the equations. That's all.
So for the conclusion, for the Volterra predator prey model, had a rich history and broad applications. So it has been extensively studied and applied in various fields due to its significance and versatility. It also was developed by Albrin and Vito Volterra and provides a framework for understanding predator-prey dynamics. So Delotka and Volterra formulated the model as a mathematical representation to show the interactions between the predator and prey population. The model is used by ecologists to study population fluctuations, predation effects on community structure and species interactions. The ecologists actually employed the Volterra model in order to investigate the dynamics of population numbers, also to understand the impact of predation on ecologist communities, and to analyze the relationships between different species. It has applications in epidemiology, economics, and analyzing social interactions, where the Volterra model finds utility in fields such as epidemiology to study the disease spread, as an example. Also for the economics, to explore market dynamics, and for social science is to examine the interactions among the individuals or groups. The Volterra model is an invaluable tool for understanding and predicting predator-prey dynamics. So the model's ability is to explain and forecast predator-prey relationships, which makes it essential and important tool for comprehending ecological dynamics. Lastly, its relevance extends to ecological research and beyond. So it contributes to diverse fields of research and provide insight into much more various and complex systems. And that's it, and thank you.